All right, so here's, although we talked a little bit about some stuff today in class, let's take a look at some of these a little bit more in detail. As far as identifying initial and terminal side of an angle, we're going to be sketching angles in standard position. We kind of talked a little bit about that today, where the initial side is on the positive x-axis. We're going to be converting between decimal and DMS form, which is degree, minute, second, and I mentioned that real quick. And we're going to define a radian and convert between degree and radian forms, and looking at coterminal angles and finding complement and supplement of an angle. Now, you've done that before, but we're going to just do it in both degrees and radians. Okay, so what is an angle? An angle contains, we have an initial side and a terminal side. Now, this is in standard position right here. This was in standard position. So when you have in standard position, you place the initial side on the positive x-axis with the vertex at 0, 0. And we have an initial side and a terminal side. Initial, that's where you start, and this arrow indicates rotation. Okay, and again, as we talked about today, a positive rotation, or the angle, is when you were going in the counterclockwise direction. So this is actually counterclockwise. And when you have an angle that is negative, we are going in the clockwise direction. Okay, and I understand that it's a little weird to hear things like kind of the way we talked about it, and that, you know, its circle doesn't really have a measurement in degrees, and I mean, you're kind of used to hearing that. However, what we're talking about is when you have this angle here, and this is the initial and the terminal side, and you can see that because it starts here, it makes one complete revolution, and it stops back on the x-axis. So when you have one complete positive revolution, that angle that has is indicated is 360 degrees. And then, of course, when you go halfway around, it's only 180 degrees. Now, this angle that's written here, okay, that's drawn, it's in standard position. It has an initial side here, and it has a terminal side here. Well, and if you do not show the direction that you're moving or how many times you're going around, you don't know what the measure is. So if you look at this angle, there's actually two angles here, actually many angles. If this angle that's drawn from here to there, that would be a 90-degree angle. And if you consider that this is the initial side, and you go in that direction, that would be negative 270 degrees. Because as you travel around, you go negative 90, and another negative 90 is negative 180, and then another negative 90 is negative 270 degrees. Okay? And also, if you continue, so if you have an angle that, say, actually starts here, and what about one that goes all the way around and stops there? What would that angle be? Well, it goes one complete revolution. That would be 360 degrees. And then it goes an additional 90 degrees. And then it's just a matter of adding those up, and it looks like we get 450 degrees. So there in pink, one complete revolution and another 90 looks like 450 degrees. Okay, and you can go as many times around as indicated, and you just have to, every rotation then would be another 360 and another and another and another, and you just have to add all those up and add that last little part that does not go all the way around, and in order to sum up a complete angle. Okay, then looking at this one, it kind of looks like the same angle. So if these two angles were just sitting around somewhere, not on the XY axis, you know, you might think that they are both 90 degrees. But as indicated, if you place the initial side on the x-axis And looking at this arrow going this way, this would indicate a negative 90 degrees. And then going the other way, we have 90, 180, 270 in the other direction. So here's just a little illustration to help you when you're doing some of these problems, is that every 90 degrees, so 90, 180, 270, 360, in the other direction, negative 90, negative 180, negative 270, negative 360. So, for example, let's say that we go around 2 times, 1, 2, and land here. So it's just a matter of adding that all up. And normally I just kind of ignore the negative for a moment, and I'm just going to add up all the values that we went around and then just tack on that last little part. So we have one revolution, which is 360. And then we went around another revolution, which is another 360. So that would be 720. And then we went around another 180 degrees. Now technically these are all negative. And then it's just a matter of adding that up. And then it looks like that would have been a negative 900 degree angle. So there in pink would be negative 900 degrees. Okay, so see if you can sketch these 3 angles. Okay, on the next page we have a couple more angles there. And just pause this, see if you can draw this in on your paper. Do it in pencil, make sure you position it in standard position, make sure you show the directional arrow indicating the initial and the terminal side, and then label it with the angles shown. So give it a shot first, and then check back to see what I wrote. Okay, in standard position, we will put the initial side on the positive x-axis, and you're just going to give it your best shot into indicating this angle. And we're at a 45 degree angle, so here's 90 here. So we're going to try to cut that in half as best we can, and we show a directional arrow indicating 45 degrees. And there is a 45 degree angle. Okay, negative 125 degrees. And again, every one of these we're going to put in standard position with the initial side on the positive x-axis, and we have to go negative 125. Well, negative 125 is between negative 90, so down here would be negative 90, right? So this would be negative 90, and if we keep going around here, this would be negative 180. So just take a look at above on your sheet. You should have indicated, the 0, 90, 180, 270, 360, and just realize that it falls between negative 90 and negative 180. And we can, if we want, to say, okay, well, how many more degrees is 125? And doing a quick subtraction. Okay, it looks like we have 35 more degrees. So we're going to come down here and say, okay, we'll come down here to 90 and about another 35 degrees, which is a little more than 1/3 of the way. And there you go, and drawing your directional arrow because it is negative. And that looks approximately to be negative 125 degrees. Okay, 495. When you draw an angle like this, the first thing you really do is determine if it is larger than 360. If it is larger than 360, you subtract 360 from it. So take 495. I don't know why I just wrote that. That should have been degrees. So take 495 degrees, where we start, and we're going to subtract 360 from that. and you get 135 degrees. Now, if the resulting angle is still bigger than 360, you keep subtracting 360, subtracting 360, subtracting 360. Since right here, we only subtracted one 360, put a C in there, we subtracted one 360-degree angle, okay, which is really just one revolution, one revolution. So we're going to have to indicate that when we draw it. So 495 is over 360, so you have to go around once, and that is the 360 degrees that we subtracted. Then we still have to go another 135 degrees, and we indicate, so we go, and that's another 90, and a 135 will be about there. And you're going to start getting used to hearing numbers like 135 and 217, or 215, say, and some other numbers that will start becoming very familiar to you. So the actual angle is this initial side and terminal side, and it starts here, goes around once, and then another 135 degrees. Okay. All right. If the radian thing confused you a little bit, let's do say let me do two of these, and then give a couple of the others a shot. See what you can do with that. For your circle here, we're going to put the initial side again on the positive x-axis in pi over 3. And from you memorizing your unit circle, you should know that the pi over 3 would be equivalent to a 60-degree angle in degrees. And I just said that. So a pi over 3 would look approximately like that. Okay, then 5 pi over 3. And perhaps we want to write up above. Let's write up above, and as you go around, why don't you make sure you have these numbers down, is that this is 0, and then of course up here is pi over 2. Now I don't write these every time. Pi over 2, and this one is pi, and down here is 3 pi over 2, and again all the way around to 2 pi. All right, so, and it may not be so easy as to figure out where 5 pi over 3 falls. It's not as easy as saying, well, you know, what was that one we had? What was it? 125 degrees. It's easy to tell 125 is between 90 and 180, so it's going to put its terminal side somewhere between, you know, the 90 and 180, or the negative 90 and negative 180 that we had. Well, it's not so easy to figure out where this falls, and it's really just sometimes just a matter of counting around. So from here, we have 5 pi over 3. Well, I would rather, and as we did in class, I'd rather count around by pi over 6s. It's hard to count around by 5 pi over 3s. Now, we can also, the first thing we did, just like with degrees, we need to determine if 5 pi over 3 is bigger than 1 revolution. Well, 1 revolution is 2 pi. So 1 revolution is equal to 2 pi radians. Okay, so we have to make sure if this number is smaller or larger. And you can tell by, if you just put 5 over 3, consider 5 over 3. Is that bigger or smaller than 2? If you're not sure, just put 5 over 3 in your calculator. Well, to get a 2, you would need 6 over 3. So 5 over 3 is smaller than 2 pi. So it has not gone around 1 revolution yet. Okay? And it's actually going to be 1 pi over 3 short of going around 2 pi. Because 2 pi is 6 pi over 3. But again, I like counting around by pi over 6s. So what I'm going to do is, I'm going to say 5 pi over 3 is equivalent to 10 pi over 6. And that's how we counted around the unit circle. We counted around by pi over 6's, which are equivalent to the 30s. So I put in little thirds all the way around. Now, again, these are not the 45s that I called them. I called these the 30s. And so if you count around by 30 degrees, this would be 30, 60, 90, 120, 150, 180, and etc. But instead of counting around by degrees, we're going to count around by pi over 6's, because pi over 6 is equal to 30 degrees. So let's go. 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2, of course. 4 pi over 6, 5, 6, 7, 8, 9, 10 pi over 6. Okay? And I'm saying this 10 pi over 6 because that's the 10 pi over 6 is equivalent to the 5/3. So this angle will start here, and it will travel all the way around to here and end right there. And there's your 5 pi over 3 angle. Okay, negative 3 pi over 2. Well, as indicated here, we have a 0 pi over 2 pi, 3 pi over 2. In the negative direction, it's 0 pi over 2 pi, negative 3 pi over 2, and negative 2 pi. So from this one, we're going to start on the positive x-axis. And we're going to go around negative 1 pi over 2, 2 pi over 2, 3 pi over 2. And it ends up just like that. Okay, 7 pi over 4. Well, it's nice. We have pi over 4s. You remember that's like a 45-degree angle. So I'm only going to put a tick mark for the 45s now. So there's a 45. Okay, the 90 is, I consider that a 45. And because it's 2 45s and 3 45s, 4 45s, 5, 6, 7. And all you do is just count around. 1, 2, 3, 4, 5, 6, 7. And there's 7 pi over 4. And also notice, we can tell that this would not have gone around more than one revolution because 7 over 4 is less than 2. Because again, 2 pi radians, if you have a 2 in front of your pi, that means it's gone around once. And if it has gone around more than once, you have to subtract off 2 pi's instead of subtracting off 3 60s, as we did with one of the ones from A, B, and C that we did on the other slide. All right, now coterminal angles, and we have to talk about these because what we'll find out is, and I mentioned this today a little bit, when we took a look at the unit circle, and we talked about the sine and the cosine, and I think it was a I forget what the angle it was. Maybe it was a negative 60 and a 300-degree angle, something like that. And what I mentioned is that because the angles, it doesn't matter where you start or what direction that you travel in your rotating, is that it all depends on the terminal side, called that when you have coterminal angles. If the terminal side ends up at the same place, that those angles will have the same sine and cosine. So we need to figure out when angles are coterminal, and then we can use that information to help us solve more complicated problems. Okay, so we need to find some coterminal angles. So let's take a look at this one, and we can see if we consider that this angle is 60 degrees, then if we start here and travel around one complete rotation, and then another 60 degrees. So one complete rotation here is 360. Okay, and then in, say, some other color, I'll put this in blue. So trying to cover that up. So that pink part there is 360 degrees, and then the blue travels that extra 60. So the 360 plus another 60 is 420 degrees. Okay, so that's where that 420 degrees comes from. It's one complete revolution with this 360 plus another 60. Now, that would be two positive numbers, two positive angles that are coterminal. Well, let's consider an angle sitting here. So let's check out this angle right there. And you can see in the positive direction, it would be indicated, let's say that we have 135 degrees. Okay, well, how do we determine the coterminal angle on the other side? Okay, and all we really have to do is, instead of adding 360 to 60, because that's what really happened. We took this 60 degrees and we added on one complete rotation. Well, let's take 135, but instead of adding 360, let's see what happens when we subtract 360 from it, because subtracting, I'm giving that arrow that way. So let's actually do the calculation. 135 minus 360. Okay, and when you do that calculation, we get a 5. And let's see what we get there. All right, we actually have to steal the 5 from there and subtract to get the 5, and we have the 6. Turns into 5 minus 3 is 2. And then 3 minus 1 is 2. So we get 225 degrees. So we do get, now we actually get minus 225. So regardless of what direction we go, if we ever want to find a coterminal angle, we can take any angle we have, and if you add 360 to it, so if you start with a 60-degree angle, which is there, and you add another 360, which is right there, because we just made a revolution, one revolution from there all the way around to here, that angle would be coterminal with 360, and we found that to be 420. And if you go in the other direction, if you take this angle, and if you subtract off 360, that will give us another coterminal angle. Okay, so let's take a look at this one. So let's say we were given a 330-degree angle as indicated below. Well, if we take 330 and we subtract 360, you should see that we get a minus 30-degree angle, which is right here. And then also with that one, let's say we take this angle here. Let's add 360 to 330. So if we take 330 degrees and we add 360, okay, we are going to get 690 degrees. So where would the 690-degree angle be? And that would be if we go around 360 and then another 330 degrees. So that angle, that rotation indicated by the pink line, would be the 690-degree angle. So all these angles are coterminal. You can have an angle between 0 and 360. You can have one bigger than 360. I mean, if you keep adding 360, 360, 360, we're still going to be getting coterminal angles. So we have an angle, we have a number 360 bigger, and we have another angle 360 less. And then if you take an angle that's between 0 and 360 and you subtract off 360, you're going to end up with a negative angle there as well. Alright, so let's end this video with this calculation. And we're just trying to find coterminal angles. And the way, again, to find coterminal angles is just to add or subtract full revolutions. And if the problem is in degrees, and so far you've only seen that in degrees, we're going to add or subtract 360 from that angle, and we will find a coterminal angle. However, if you're given an angle in radians, we are going to add plus or minus 2 pi, okay, to that particular angle. So let's find some coterminal angles with 210 degrees. Well, if you take 210 degrees, so let's just start 210, and you add 360, okay, looks like we get 570 degrees. Okay, then if you add another 360 to that, so now we're taking 570 degrees, and you add 360, we are going to get, looks like 930 degrees. Okay, now We found two positive coterminal angles. Now we need to find two negative coterminal angles. So let's go back to our 210 degrees. So let's take 210 and let's subtract 360. And let's try to write it a little better. So we're going to subtract 360 degrees. And in doing that, it looks like we have a negative 150 degree angle. And then you take the negative 150 and you can subtract off 360 again, and you get negative 510 degrees. Okay, so all of these angles are coterminal. If you place their initial side on the positive x-axis and you lay them on as we have before and just sketch them out, that their terminal side will all end up at the exact same spot. And as indicated before, all of these angles would have identical sine, cosines, and tangents, and etc. So if you want to just give it a shot, find the sine of 210 degrees, find the sine of 570 and 930, and all these other angles, and you'll find that that value that your calculator gives will be exactly the same. Okay, so I'm going to do this one for you, and you get to do that one. Okay, so let's do pi over 4. Well, if we start with pi over 4, because we start with radians. Now, soon here, and starting the next video, we're going to be converting angles back and forth from degrees to radians. Well, if your problem starts with radians, you're under no circumstances allowed to convert back and forth to help you solve problems, because what's going to happen is you're going to have to convert twice. You're going to convert once and back into degrees and back into radians. Well, I don't want you converting back and forth, and I don't want you just going back to degrees, because that seems really easy, okay? You need to start learning about radians. You need to work with radians and learn about them. If you keep worrying about degrees, you're not going to be practicing in the radians, and it'll just be more difficult. So let's take pi over 4, and we need to add 2 pi radians to it, okay? And when you add with this, you see that you have a common denominator 4. So we need to make this a common denominator 4, denominator 4 here. So we put a 4 here, and we also have to multiply the top by 4. So you should see that this is pi over 4 plus 8 pi over 4. And you see that the 8 over 4 would give you a 2. And then you just add that up. So we have pi over 4 plus 8 pi over 4 is 9 pi over 4. It's really not that bad. So the angle 9 pi over 4 would be an angle that's bigger than 2 pi. Because you see 9 over 4 is bigger than 2. So we know that this angle is bigger than 1 revolution. And this angle would be coterminal with pi over 4. Now we need to take that 9 pi over 4 and we need to add another 2 pi. Well, since we have fourths, you're going to get in the habit of probably, after you do this numerous times, instead of just writing 2 pi, since we already added 2 pi, which turned into 8 pi over 4, let's just write 8 pi over 4. We know that's the equivalent of 1 revolution in fourths. So let's just add that. And 9 pi over 4 plus 1 full revolution, which is 8 pi over 4, is 17 pi over 4 radians. You just don't write radians. All right, now we need to subtract. So let's go back to our original angle, which was pi over 4. And now we need to subtract 1 full revolution. So we're going to subtract 8 pi over 4. All right, so this one is 1 pi over 4 minus 8 pi over 4 is negative 7 pi over 4. And then now we need to take that and subtract off another revolution. And it looks like we would get negative 15 pi over 4. All right, now in some of my calculations, be careful with the negative sign. I know like the negative sign appears up here and down there sometimes. Try to put the negative sign out in front. Don't try to attach it to the top or the bottom. I mean, it really should kind of go right out in front next to the little fraction sign. Right out in front there. Maybe a little lower in this case, so you're writing them properly. Like right here, when this negative sign is sitting right out in front, do not attach it in front. It's not negative 2 pi all over 3. It's a negative value, and the angle would be 2 pi over 3, and it's negative. Okay, so that really does need to go out in front. Okay, I just wrote these kind of quickly, and just be careful with those. So I would like you to do the math that we did down here. Now, because this is thirds, just realize that you're going to be adding 2 pi each time. So if you start with negative 2 pi over 3, I'll just kind of get you started a little bit here. So let's ignore all this other stuff for a moment. We'll get rid of this real quick. Okay, so let's start with that. Now, oops. A little better, sorry. Let's start with that. And then we're going to be adding 2 pi. And since we're going to be adding 2 pi, and usually for the first time I write that because we're going to still deal with thirds in a minute. And since this is negative 2 pi over 3, then I'm just going to convert the 2 pi. And 2 pi, but we have to have thirds, would be 6 pi over 3. So in each case here, just continue adding 6 pi over 3 and get two values here. And then also start with the negative 2 pi over 3 and subtract 6 pi over 3 and get a measurement here and here. And we can find out what the answers are when you come to class.